Hello students, my name is Shesi George, your professional accounting teacher. Before you continue with this video, please try to subscribe to my YouTube channel, Georgian Theory Concepts. Okay, so let's get started. In this video, I'm going to show you the concept of histogram. That is one of the graphs for presenting statistical data, okay, by looking at this very question to demonstrate that. So let us get started. The following data represents scores of 50 students in a statistics test. All right, these are the raw data. The raw data has been given. Then Roman figure 1 says prepare the frequency distribution table with the first class having a lower class of 40 and a class width of 10. A class width of 10. Then 2 says that draw the histogram for this data set and use it to estimate the mode, and use the histogram to estimate the mode. Okay, so the first thing is to prepare the frequency distribution table as follows. So you have your class limits, the class boundaries, the tally, and the frequency. All right, then the question says prepare a frequency distribution table for the class having a lower of 40. A lower of 40. So you start from here, 40. Then they said a class width of 10. A class width of 10. A class width of 10. So from 40 you count 10. You count 10, that's 41 to 49. That is 40 inclusive. Okay, then the second class we start with 50. We have 60, 70, 80, then 90, then hundreds. So if you look at the highest figure here, the highest data here is 100. Okay, when you look at, so you stop at 100. Then the class interval 50 inclusive. So we have 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, and 100 to 109. So that is the class width of 10. All right, so 40 inclusive, class width of 10, 50 inclusive, and so on. Then the class boundary, like I said, you take minus 5 from here. So this one will start with 39.5 to, you add 0.5 to this, that's 49.5. You take 0.5 from there, so we have 49.5. Then this is 59.5, 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5. Then we have 89.5 to 99.5. Then we have 99.5 to 109.5. Okay, now comes the tally. Tally means frequency when represented with stroke. You represent with stroke. Okay, all right, so we now look for data that falls within this class, okay, within this range. All right, so from here this logic is either you go horizontally or vertically, horizontally. Okay, so let us look for data that falls here within this range. So let me go vertically, let me go vertically, let me go vertically, let me go vertically, vertically. All right, okay, So I'm having 49, that is 1. So the tally is 1 and frequency is also 1. Okay, so we continue in that respect. Are you with me? Then we go for this. What are the data that falls within this range? So you start from the beginning again. That is 50 to 59. This is 1. 50 to 59. This is 2. And this is 3. 3. 3. Okay. 3. 3. 4. 4. Okay. 4. Then this is 5. All right, that's 5. So we have tally 1, 2, 3, 4, and 5. Then frequency is 5. Okay, so you continue that way for the third class. That is data that falls within this range for the third class. That is 60 to 69. 60 to 69. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so you have tally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then you have your 16. Okay, so if you continue that way, and the last one is frequency is 1. Okay, so this has been done. That is your frequency distribution table. So the next question says to draw the histogram and use it to estimate the mode. So the next thing is to take your graph book. So having gotten your graph sheet, you need to do your scaling very well. All right, so for your scale, you can count 10 boxes and start with 2. Okay, because if you look at the highest frequency here is 22. So it will be okay to start with 2, 4. It must be drawn to scale. 4, 6, 8, 10, 12, 14, 16, 20, okay, and 22. All right, so drawing to scale, then you against the class boundaries. Okay, against the class boundaries. So you have your class boundaries here. The class boundaries. Then you have your frequency here. You write your frequency. Okay, then you have your class boundary on the x-axis. All right, now what is a histogram? Histogram is nothing but a graph that consists of rectangles drawn to represent a group frequency distribution. It is a rectangle drawn, that is histogram. Okay, this is histogram. Okay, all right, now let's draw the histogram. Then this is class boundary. Like I said, if you look at the class boundary, you start from 39 to 49. So you come here, you write, I will start from here, 39.5, 49. So you start to write this 49.5, 59.5. This is 69.5. This is 79.5. This is 89.5, and you have 99.5. Then you have 109.5. Okay, that's on the x-axis. All right, then the first, you now start to plot against the class boundaries. All right, frequencies against the class boundaries. So that is histogram. Then the first will be drawn from here. You can do a sign like this. Then it's 1. So your 1, you count 5 boxes up. So you are going to count 5 boxes up. That is 1, 2, 3, 4, 5. So this is where 1 lies. So you draw you use a transparent ruler. All right. Then the second frequency, the second class is 5. Of course, 5 will be, you count from 4. Just count 5 boxes. So 5 boxes represent 1 unit. So let's count 1, 2, 3, 4, 5. All right. So it represents 1 unit. Okay. Then you draw. Then you join this. Oh, all right. Sorry, it's supposed to be here. Then you join this. Okay. Then you draw this down. Then the next one is 16. So 16, the third is 16. All right. So join this down. Just draw. And this. Draw. Then draw a rectangle. This is a histogram. Then the next one is 22. Of course, the 22 comes here. Just join it with this and draw down. Okay, you draw down. All right. Then you join this rectangle. Then the next one is 4. Of course, we have 4 here. This is 4. All right. So you join and come down. Then the last 2 is 1 and 1. All right. So don't forget, you count 5 boxes up. 1, 2, 3, 4, 5. Then you join. That's for the 2. For the 2 last classes, they are the same frequency. Then you join and join. Okay. All right. So this is your histogram. The histogram has been drawn. Now the question says we should estimate. If you look at this question, they said draw the histogram for these data sets and use it to estimate the mode. So I'm going to show you how to estimate the mode. So to estimate the mode, you join the vertex of this, you join it to the vertex. So the longest triangle is the modal class. So the modal class is the class with the highest frequency. So the highest frequency is 22. And as a result of that, it gives us the longest bar. So you are going to join these two opposite vertices together. You join. All right. Then you join this with the other class. We need a very long ruler. Let me take a long ruler. So this is a very longer ruler. Can join then you join it to the other from here. And see what I've done. Join it to the other. So having joined this vertex with this edge, you join this vertex with this. Okay, now where these two lines intersect will be traced down to the class boundaries. So let us trace this down from the intersection. You can see. So you need to be very careful. You need to trace down with your ruler. Just trace down. Okay, then we have it here. All right, so this is the mode. Now we need to read this graph here. So if you look at this, the intervals here, it means that each box, the interval is 10. Don't forget, it's 10, the intervals. The width, the class width is 10. It means that each box represents 1 unit. Okay, so since we have 1 to here, so you now add it to what is here. What do we have here? We have 69.5. So we are going to have 69.5 plus 2. Okay, and that will give us 71.5. All right, so you now write from here. You see our B12 will be from the graph. The mode is estimated to be 71.5. 71.5. Okay, so that is the end of this question. Please, if you understand this question, please share with your friends. You can rewatch the video. So this is how to draw a frequency distribution table and a histogram and estimation of mode from the histogram. Thank you. God bless you. Bye.